Good morning, good evening, good afternoon, guys. So today we'll be looking into about Kubernetes service. Okay, so before talking about Kubernetes service, we need to understand the basic part of Kubernetes networking. Okay, then we need to understand about what is the problem that the pods are facing during the communication time. And what is this Kubernetes service and how that is going to be helpful. Okay, and followed by we'll look into how Kubernetes service architecture actually works. We'll be looking into the labels and selectors. We'll also try to understand what is endpoints in Kubernetes. We'll try to see kube proxy and how this traffic routing actually works, and what are the types of Kubernetes service we have. Okay, like cluster IP, node port, load balancer, headless service. And we'll also look into like service ports. Okay, like what are the service ports that we have, like port, target port, and node port. And followed by we'll also discuss about this node port ranges, followed by DNS and service discovery, and followed by a real world architecture example. Okay, so these are the topic that we'll be discussing today. So first we'll be going with Kubernetes networking basics. So guys, in the Kubernetes networking, okay, so basically this Kubernetes networking will follow these three main rules. One is every pod will have its own IP address. Okay, another rule is with the help of that particular IP address, so the pods to pods can able to communicate with each other directly. Okay, your pod 1 can able to communicate to pod 2, your pod 2 can able to communicate with pod 3, all that. And rule number 3 is nodes can communicate with pod without using any kind of transition, any kind of NAT translation. Okay, so guys, if you want to observe here, let's say in my case, let's try to check whether this node, this worker node, can able to communicate with the pods or not. So for that, let me check, do I have any kinds of a namespace kubectl get ns. In the namespace, I would have run some pods. Okay, so I have one particular namespace like demo project. Let me try to check the pods, kubectl get pods hyphen n the namespace, and the namespace is demo hyphen project. Okay, so when you observe here, yes, but I could see only that particular pod name, and I could see only the status. I want to look into the complete details of it. So if you want to look into the details, you can run -o, that is output, and you can give wide. So when you give -o wide, you get the complete information. That is, you get the IP address of that particular pod, followed by on which particular node it is actually working. You get all those details. Okay. Now I understand that. See, according to my cluster architecture, you can see I have only one master node and only one worker node. So all the pods in future, if I'm deploying or if I'm trying to run any kinds of pods, all that are going to run on my worker node only. So now I'll try to get the IP address of the particular pod, and I know the pod is going to run on my worker node. Let me copy down the IP address. Maybe like, let's say I'm going to copy down this WordPress pod. Copy down this. Go to your worker node and try to run this ping command. So with the help of this ping command, I come to know that whether this particular worker node could able to communicate to the pod or not. So when I give enter here, so you can able to see there is a packet stabbing going on. Yes, there's a transaction is going on, which means yes, this particular worker node could able to communicate to your pod. Okay, it can able to communicate to your pod. It doesn't require any kind of NAT translation. Okay, it doesn't require any kind of NAT translation. So the problem with the communication, like the problem with the pod communication is, see, you need to understand here, pods are not permanent. Pods in nature are ephemeral, which means, let's say for example, we have a front-end pod. The front-end pod is trying to connect to a back-end pod. Okay, see, I told you every pod will have an IP address, right? Maybe the front-end pod is using the back-end pod IP address and it's trying to connect. Now, suddenly, if your back-end pod get crash, okay, what will happen? It will again recreate a backend pod with this time with different IP address. So every time when the pod is newly getting created, every time it's come up with a new IP address. So this generally creates a lot of problem when there is a pod to pod communication, or if there is any end user who's trying to communicate to a pod. This creates a lot of problem here. Right. So to overcome this issue only, we are going with services. Okay, we are going with Kubernetes service. So guys, this particular Kubernetes has released one particular object called service. So with the help of service, what we can do is we'll get a stable access point. which means we can even call it as we'll get a stable IP address, we get a stable cluster IP address. With the help of that particular cluster IP, we can able to communicate to that particular pod. Okay, so what is this Kubernetes service? See, a Kubernetes service provides a stable access point to access your pods. Okay, to access your pods. So instead of connecting to pods directly, application connect to service IP. Understand this properly. Last time you see the pod was directly communicating to another pod by using the IP. Right, or the end user who was trying to connect to that particular pod by using the IP address. So at this time, okay, with the help of the service, you don't have to connect to the pod IP, guys. Instead, you can connect to that particular service. Okay, the service will have the endpoints. So here the endpoint is nothing but the IP address of your pod. You'll understand that slowly, okay? See, instead of connecting to the pods directly, applications connect to the service IP. Okay, so that is what it is. Now we'll try to understand, okay, the service architecture. So guys, previously in my previous class, I would have explained about the manifest file, and I've also showed you some example like how this particular end user could able to communicate to the pod by using this service, right? By using a service type like node pod, all that. See, in previous class, I showed you like there's a user. That user will mention the IP address of that is the node port, that is 192.168 something that like that. I mean, okay, that will connect to that particular service which is there in that particular worker node, and from there it'll go to that particular pod. Right. So this was some kind of beginner level understanding. So in beginner level understanding, what you understand is the user will be there. The user will just mention the IP address followed by the port number of that particular worker node, and that will connect to the particular service. Okay, that will connect to that particular service or the cluster IP service. Okay, from there it will connect to the pod. Okay, so this is just a beginner level understanding. Okay, this is a beginner level understanding. You guys have to understand the complete architecture, how actually in the background it is actually gonna work. Okay, how will this particular cluster IP is going to route the traffic to that particular pod? How is this all happening? So all that you'll understand through the service architecture. Okay, service architecture. Okay, yes, guys. So now let's try to understand the service architecture, guys. See, what you need to understand here is, let's say, for example, okay, I'm an end user. I want to connect to this particular pod. For example, let's say, uh, one second, I'm an end user. I want to connect to this particular pod. Okay, I want to connect to this particular pod. Okay, so what I will try to do, maybe we'll, right, in the previous class, we have written one particular manifest file. Okay, for deploying, we have written one object like deployment. We have ran some 3 pods of Nginx, and followed by we also written one service YAML file. In the service YAML file, we've written the complete detail, like what type it is. The type is like node port, okay, something like that. And we have also mentioned what is the port number of that particular service. It is going to listen on 80. And what is the target port that is going to listen on some other container port number. So your container port number should be exactly matched to your target port. Okay. And we also mentioned one more port, that is like node port number. Okay, like we have mentioned one particular port number like node port. The node port we have mentioned like somewhere like 30,030, something like that. Okay, I'll explain what is that node port. You'll come to know later. But we have mentioned like this, right? So we created one deployment file, and using the deployment file, we deployed some pods. Right. And now I want this pod to be externalized. I want that pods to be used by a user. So I have created a service. See, with the help of this service only, the user can able to connect to that particular pod. So how is this going to happen? See, let's say, for example, I'm an end user is there. So this end user, first what he'll do, he'll try to mention the IP address. So whatever the IP address that particular service has been released. Let's say we have running a service like node port. Okay, when you run a node port, what will happen? All your worker nodes will be exposed with that particular node port number. Okay, all your worker nodes which is there in the cluster, everything will get exposed with that particular port number. So the end user can connect to that particular port by mentioning that particular node IP followed by the node port. So when he's trying to connect, let's say for example I'm a user, okay, that user is mentioning the IP address. That is, for connecting to the pod, he'll mention the IP address 192.168.12.10, something like that. Okay. So what that will happen, that will go to that followed by even the node port number, like something like 30,030. Okay. What that is going to happen, that first it will connect to that particular worker node. Okay. First it will go to the worker node. Okay. To whichever the IP has mentioned, it will go to that particular worker node. See, in every worker node, we have something like kubeproxy. Okay, so in every worker node, we have something like kubeproxy. See, the main job of your kubeproxy is it is going to do two operations, guys. It is just going to do two operations. So first operation is it is going to set IP tables. Second operation is going to group for a DNAT translation. What do you mean by DNAT translation? See, let's say, guys, whenever a user is trying to mention the port number followed by this particular IP address of your worker node and followed by the node port, what will happen? That will go to your kubeproxy, and your kubeproxy will communicate to your Linux kernel. Okay, and your Linux kernel will actually translate your node port. That is, let's say your node port is there like 192.168.12.10 and followed by this port number 30,030. Okay, this will be translated, this will be DNAT. Okay, this will be DNATed and will be translated to your cluster IP. Okay, to your cluster IP service. Okay, your cluster IP, maybe your cluster IP will be like 10.12.1.10 followed by whatever the service port number is there, 80. Okay, it will be DNAT there, and it will be store these details in the IP tables. Why it will store? Because the end of the day, okay, your kubeproxy is the one who is going to route the request to that particular pod. See, whatever the request that is coming from the API, see, the user is hitting this. Okay, from there what will happen? It will go to the API server. If you know about the architecture, you'll understand this. You'll go to the API server, and your kubeproxy will try to check the request, whatever the request that is coming from API server. It'll actually store that request. Like, it'll come to know that, okay, what are the pods that are running, what is the IP address should be there, and what is the cluster IP that is going to get DNATed from your Linux kernel. So it will actually store that into a table, telling like, okay, so this is like my cluster IP. For example, let's say this is my cluster IP, like 10.12.1.10 followed by a port number. So this is going to manage these pods like pod, Nginx pod 1, Nginx pod 2, Nginx pod 3. It will have that IP address 192.168, 192.168.1.2, 192.168.1.3. So everything will be stored in the table. Now what will happen? Now I told you, right, the end user will be there. The end user will just mention the IP address of your worker node followed by the port number, node port. Okay, that will connect to your worker node, and from the worker node it will go to your kubeproxy, and your kubeproxy will route the request to your cluster service, and the cluster service will work to that particular pods. It will connect to that particular pods. Now you will be having a doubt here. How come my cluster IP, or how come my kubeproxy comes to know that, hey, this particular cluster is going to manage these other ports? How it will come to know that? See, generally, guys, when you're writing a service YAML file or a service manifest file, I think I would have showed you this. If you want, I can again show you here. See, if you observe here, in the manifest file, what and all we have written here, especially when you are writing a service manifest file, we would have mentioned like, how will my service will come to know that these are the pods that I have to manage. How it is going to come to know here? See, we have something like selector. In your service, we have something like selector, and your selector is having some kind of labels like app nginx. See, whatever the labels your selector is having, that label should match your pod labels. Even in your pod also, we'll have these labels. Okay, if the labels of your pod labels is same, then your service will understand, okay, these are the pods that I have to work with. So in my case also, you can observe here that, one second, in my case also, you can come to know that, yes, we have written this, right? So even in our pods also, so pods also are using this labels as app nginx. So from here, my service will come to know that, okay, these are the pods I have to work with. So I'm going to have 3 replicas, which means 3 pods are going to run. Okay. So your service is going to manage these 3 pods. Okay, so you understood, right? So generally, guys, the architecture is very simple. It's not that difficult here. Let's say the end user is there. The end user has to connect to the pod. Okay, for example, the end user is there. The end user has to connect to this particular pod. Okay, he has to connect to that particular pod. How is going to connect? So with the help of this particular service, like maybe the node port service, okay, whatever the node port IP address you mentioned, he'll use that IP followed by the port number, like 30,030. You'll come to know why the port number is 30,030. Why not it's some other port number? You'll come to know there. Okay, when you're using node IP and when you're exposing this node port, what will happen? All your worker node will be exposed with this particular port number 30,030. So in your cluster, maybe you will have like 2 to 3 worker nodes. Those 3 worker nodes will be exposed with the port number 30,030. Now let's say you are using any one of that particular node IP, okay, and you're giving that particular port number. So when you're giving like this, what will happen? So from here, we have to connect to that particular pod, right? What will happen? From here, it will go to your worker node. In the worker node, by default, guys, in every worker node, we'll have this queue proxy. Okay, we'll have this queue proxy. Basically, guys, according to the Kubernetes architecture, queue proxy is actually useful for related to networking purpose. Okay, with the help of this queue proxy only, all the pods are getting the IP address and pods could be able to communicate with each other. Okay, so what this queue proxy will do is in the queue proxy, there are going to be 2 operations are going to be there. Okay, 2 operations that is going to happen. One is, first thing is, what is going to happen? First thing, it will set the IP tables. Second one is it is going to set the DNet translation. Okay, what do you mean by DNet? See, for example, guys, whatever the IP address request is coming, so what will happen? This queue proxy will actually talk to your Linux kernel. Okay, it'll talk to the Linux kernel, and Linux kernel will actually create one particular cluster IP, and this queue proxy will route the traffic to that particular cluster IP. So now this Linux kernel, what it'll do is your queue proxy will talk to your Linux kernel, and whatever the node port, let's say your node port IP is, you'll be getting the request like this, node port followed by 30, 30, 30. So this request will be getting to your queue proxy. Your queue proxy will talk to the Linux kernel. He'll do a DNAT translation. So he'll give the cluster IP. Okay, like 10.1.12.10 followed by whichever the port number the service is actually, the cluster IP service is running. So he'll be mentioning this particular thing. Okay, these details will be maintained in the tables. Okay, in the IP tables, we'll be maintaining like, okay, this particular service, that is your cluster service, cluster IP service, okay, 10.12.10.80, he is going to manage which are all the pods. So here we'll be writing down the IP address of your pod, which means the endpoint. We'll be managing the endpoints. So your endpoints will be written inside this particular IP tables. So which means your queue proxy will route the request to your cluster IP. Your cluster IP will route the request to that particular pods. Okay, so this is how the end user could be able to connect to this particular pods. I hope this should be clear here, guys. I hope there is no doubt here, right? Okay, fine. So very simple concept, guys. You guys have to know only about the queue proxy. See, here the main thing is queue proxy only. So generally, guys, as I said, you can see here, if there is any client or any end user, what he will do, he'll just mention the IP address. Okay, that is node IP followed by some node port number. Okay, that will connect to your worker node. In the worker node, it will go to the queue proxy. It will route to your request to the queue proxy. Your queue proxy, see, by default, your queue proxy will get the request from your API server only. Okay, from the API server, it'll come to know if there is any deployment is happening. It'll come to know, okay, which are all the pods and what is the IP address of those pods and which particular service has to manage. All that it will be storing those information. Okay, so from here, your worker node will go to the queue proxy. Okay, and your queue proxy is going to set some IP table rules, which means which particular service is going to manage which particular pods. Okay, maybe see in your cluster there would be a lot of service would be there. Okay, a lot of service would be there. Okay, so how come your queue proxy will understand? So that is where your queue proxy will set IP table rules. Okay, it'll set some IP table rules. It'll come to know, okay, this particular service is going to manage this particular endpoints. I mean, endpoints are nothing but the IP address of your pods. Okay, yes. And then it is going to go for a DNAT translation, guys. I mean, like, right, whatever the request we are getting, the node IP followed by 3080, from there it will go for a DNAT translation. You will get the cluster IP. That is, your Linux kernel will provide a particular cluster IP, 10.96.12.55. Okay, then this cluster IP service will do the load balancing. I mean, according to the IP table rules, see in the IP table rules, we would have mentioned a cluster IP, followed by we would have mentioned which are all the endpoints that this cluster IP should manage. I mean, this cluster IP service should manage. So according to that, it is going to work. Okay, according to that, this particular cluster IP service is going to do a load balancing. So guys, also you need to understand here that your service by default, it is going to provide this load balancing. It is also going to provide one particular, that is, see, service provides load balancing across pods. Okay, so what do you mean by load balancing? See, whatever the request is coming, let's say I'm a client, I want to check into the Nginx pod. So like that, there will be some 10 clients who will be connecting to your particular cluster to see this particular application which is running on the pod. Okay, so this particular service by default, it will actually provide this load balancing. So let's say I am the first user, he'll connect to this pod, and the second user will route the request to the second pod, and the third user will be routing this request to the third pod. So wherever it'll maximum will try to reduce the load. Okay, try to reduce the load in the pods. Okay. Okay, so I hope you understood this. Yes, so this is very easy only, guys. See, I told you, right? So basically this DNAT is nothing but destination network address translation. Okay, this DNAT is nothing but destination network address translation. So you need to understand this. See, whenever an end user is mentioning the IP address followed by the node port, since it is a node port service, the port has been exposed on every worker node in the cluster. I told you, right? So when you're using a service type as a node port, what will happen? All your worker node will get exposed with the port number 3080. Okay, when the request reaches a worker node, the node runs a component called kubeproxy. So I told you, in every worker node, we'll have this kubeproxy. Okay, so the job of this kubeproxy is to watch the Kubernetes API server and detects the services and endpoints. So based on the information, kubeproxy installs IP tables rules inside the Linux kernel. Okay, so these rules define the incoming traffic should be routed. So when the traffic when the traffic at the end node, when the traffic arrives at the node on the node port, the IP tables rules created by the kubeproxy performs DNAT, that is destination network address translation. Okay, the translation changes the destination address of the packet. Okay, like previously, right, we would have get the request from the node port followed by the node port number. After translation, what will happen? We'll get the cluster IP followed by the port number. Okay, and end of the day, this particular cluster IP service is the one who is going to connect to that particular endpoints. Okay, so you can see here this particular IP address in the cluster IP of the service. Okay, so the cluster IP represents the Kubernetes service, and the service maintains a list of endpoints which are the actual pod IP address selected using the service selector. Okay, for example, this would be your endpoints. I told you, right? All these details will be written in the IP tables, guys. So who is going to do that? All your kubeproxy, he is going to maintain the IP tables, and whatever the request that is coming from the end user, that will be going for a DNAT translation, and from there he will set the IP tables, and according to your IP table rules, it is going to route the request to that particular cluster IP, and the cluster IP is going to route the request to that particular pod. So this is how generally it is going to work. Okay, yes. Okay, so that's it, guys. And now you need to understand what is this labels and selector. So I told you, right? See, generally the service is going to identify the pod by using this labels only. Okay, see, by default, the service, the pods will always have the labels like app nginx and the service selector. Okay, in the service, we have something like selector. So selector is going to have a label like app nginx. So selector is the one who is going to select that particular label, and it is going to check whichever the pod which is having the label of app nginx, which means we have to manage. This particular service has to manage these particular pods. Okay, so according to the labels only, your service automatically finds all the pods with that particular labels. Okay, yeah, fine. And what are these endpoints? See, endpoints represent the actual pod IP address, guys. You need to understand here. Endpoints represent actual pod IP addresses. actual pod IP addresses. Okay, yes, that is what it is going to do. Okay, and what is this queue proxy? See, this is the most important component, guys. You need to understand about this. Okay, queue proxy runs on every worker node. Okay, so its job is to route traffic from service to pods. Understand this clearly. The job of your queue proxy is to route the traffic from service to pods. Okay, what are the responsibility that your queue proxy is going to have? So it is just going to watch the Kubernetes API and detect the service changes, creates the network routing rules, sends traffics to the correct pods. Okay, very simple, guy. Very simple. See, in future, guys, if let's say you guys created one particular deployment file, okay, so which means you're trying to run a three pods, which is of Nginx. Okay, you're running three pods, which is of Nginx application. Okay, and you're also exposing that particular Nginx application to the externally to the end user. Okay, externally to the end user. So for that, you will write a service file. Okay, in the service file, what you will do, you will mention something like node port. Okay, a node port, type as node port, which means, if you're mentioning the type as node port, means we are externalizing the node, all the worker nodes which is there in your cluster, followed by that particular port number, this particular port number, that is 30,007. Okay, so what is going to happen? See, let's say for example, we have an end user. The end user has to connect to this particular pod. So what happens here is, see, when you try to execute this particular service manifest file, so anyway, according to this particular selector, it comes to know these are the pods it is going to manage. Okay, and what is going to happen here? So now, what is going to happen here? So this selector will come to know that these are the pod it is going to manage. So it'll come to know that it'll go to the deployment file. In the deployment file, we have run three pods, right? And the three pods are having the same Nginx application, and it is also having the label as app Nginx. So now now your service will come to know that these are the pods that have to manage. Okay, and what is your service name? Your service name is Nginx service. Okay, so what will happen here is, since guys you are going like with the type as node port, the end user, what he'll do to connect to that particular pod, okay, so he will just mention the IP address of that particular worker node, that is 192, whichever the pod. Let's say for example, in my case, only according to my cluster, there is only one worker node and one particular master node is there. So what he'll do, he'll mention the IP address 192.168.12.10. Okay, this is my worker node IP address, followed by whatever the port number that has been exposed, 30,007. So he will just give the IP address. Okay, what that will happen, that will actually go to that particular, first it has to enter to the cluster, right? So the request will go to the API server. From the API server, it will go to that particular worker node, and from there it will go to that particular queue proxy. Okay, the queue proxy will read the request that is coming from the API server. It'll come to know that, okay, three pods are going to run, and these three pods are going to be managed by this particular service. Okay, that is this particular cluster IP service. Okay, so what this particular queue proxy will do here is, queue proxy will do two operations. I told you, right? It's going to do two operations. First operation is, it will actually do a DNAT translation. Okay, it'll do a DNAT translation. It'll talk to the Linux kernel, and Linux kernel will create one particular IP transition. Okay, that is like, it'll create one particular cluster IP, that is 10.12.1.10. Okay, yes. Then followed by whatever the service port number is there. Okay, now what will happen? The DNAT translation is going to happen. But before that, it is also going to set an IP tables, guys. It will set an IP tables. IP tables is like, for your queue proxy to understand, okay, this particular service is going to manage which are all the ports. So how it will come to know? It will come to know only from the request of your API server. See, your API server will actually give some request to your queue proxy. To your queue proxy, telling that, hey, these are the pods, and the pods are having this IP address, and followed by this is that particular external service that the user is trying to request. So what will happen? It will set one IP table. Okay, in the IP table, it will do a DNAT translation. After that, it will come to know, okay, this is that particular cluster IP. In this cluster IP is going to manage this particular endpoints. Now this particular queue proxy, it will go to that particular cluster IP service. Okay, and the cluster IP will connect to that particular pod. So this is how generally the architecture actually works. Okay, this is how generally the architecture actually works. See, the user is there. The user will try to connect to that particular um, IP address that has been mentioned by the node port, okay, followed by the node port number 30,030. Okay, that will actually send the request to the API server. Okay, and the API server, right, the background operations is going to, so your your scheduler will so that will go to the scheduler, and scheduler will tell to create some pods. So that request will again go back to the API server, and API server will go back and talk to your particular queue proxy. Okay, and your queue proxy will try to check that which all the pods are running and what is the IP address. It will actually store that IP address information, okay, of your pods, followed by whatever the service that is going to run, the cluster IP. So it is going to talk to your Linux kernel, and it is going to do a DNAT translation, and in whatever, and it is going to maintain an IP table. That is like this particular cluster IP service is going to manage which are all the pods. Which are all the endpoints. So according to that, it'll connect to that particular cluster IP, and from there it'll connect to that particular pods. Okay. So in general, what is going to happen here is, see, the end user is there, right? He will mention the IP address 192.160.12. and 30,007. Okay, that what will happen? That will actually connect to that particular. So with the help of queue proxy, that will connect to that particular service. And with the service port number, see here we have the port number 80. That is nothing but the service port number. Okay, with that particular service port number. Okay, your cluster IP, maybe your cluster IP is 10.12. Something like that, colon 80, the service port number. Okay, from there it has to connect to that particular target port. So your target port is nothing but your container port. See, make sure your target port should match your container port. Only then, no, your your cluster IP service is going to route the request. Otherwise, it is going to create a problem. Okay, make sure your target port number should exactly match your container port. See, in my container port also, if you observe here, guys, if you look into my container port, in my container port also, you can able to see, yeah, you can see here my container port is 80. So your target port should be exactly the same of your container port. Only then what will happen, your cluster IP could able to communicate to this particular pod. Okay, this is very, very important. I hope this is clear, right? Okay, so this is all about the service, guys. In the next class, we'll be discussing about the types of service. We'll be looking into all the other topics. Okay, I hope this should be clear here. Thank you all, guys.